In this video, we're doing vertical projectile problems, so you are more than welcome to pause the video and attempt the problems. Right, now let's begin. Q3 and 3.2. Right. So the question states a ball is projected vertically upwards with the speed of 10 meters per second from point A, which is at the top of an edge of a building. The ball hits the ground after 3 seconds. It is in contact with the ground for 0.2 seconds and then bounces vertically upwards, reaching a maximum height of 8 meters at point B. See the diagram below. Ignore the effects of friction. All right. Now, first one, why is the ball considered to be in free fall during its motion? Very good question. Now, the ball is considered to be in free fall during its motion because only one force is acting on the ball, of which is gravity. So that's how you answer the question. You didn't define it, you just answered it. Right, now calculate the height of the building. All right, so they want us to calculate the height of the building. We know that it is projected upwards. All right, so what do we have? So we do have that the V initial is what? It's 10 meters per second. And what else do we have? We know that A it's 9.8 meters per second. And I'm taking up as positive, by the way, so it's going to be negative. And what else do I know? I know that my change in t, they said the ball hits the ground at 3 seconds, so it's 3 seconds. Good. So I'm in the correct way. Good. So after this, what can I do? I can now use this equation, which is the change in y. Let me write it here. Change in y is equals to v initial change in t plus 1 over 2a change in t squared. Alright, so after this, what can I do? Substitute my 10, my change in t, which is 3, my 1 over 2, negative 9.8, and 3 squared. Right? My change in y, my answer is what? It's negative 14.10 meters. Now, since we know that there's no such thing as a negative height, we can say the height is 14.10 meters. But when you're going to be doing the calculations, you'll be using the negative 14.10. Right, now let's go to 3.2.2. The speed with which the ball hits the ground. Alright, so they want the VF. Right? Seems fair enough. So since they want the VF, what can we say? We know that the V initial is what? It's 10 meters per second. And the A is 9.8 meters per second. And we know that the time is what? It's 3 seconds. And I hope that you guys are noticing every time I'm doing the vertical projectile problems, I write what I have. It's important for you to do that. It's your data, by the way. Right, so you can use this equation of VF. It's equals to V initial plus a change in T. Right, so the V initial it's 10, and this one, remember, it's negative 9.8, and the time it's 3 seconds. Right, so the VF, then it will be how much? It will be negative 19.40 meters per second. Since we know there's no such thing as a negative speed, we know that the VF will be what? Negative 19.4. Right, now you can do this. You are more than welcome to leave it as a negative 19.41. You would still get a mark. It's no problem. But then please just write it in this way, because it shows that you know the difference between a scalar and a vector. And so for someone who's arguing with me right now, oh, say velocity, it's not a scalar. Oh, blah blah blah. No, remember they said the speed. So yeah, speed, it's just a scalar. It doesn't have a direction. Right, now let's move to 3.2.3. It's a bouncing type of question, this one. Now they say calculate the speed with which the ball leaves the ground. They want the speed at which the ball left the ground to go up. Now, what is that speed? We are to find out right now. So, what do we know about this ball? We know that its v initial was what? We don't know it, right? At this point, right? We only have the v initial at which it was projected upwards. Now we don't know the v initial at which the ball will go up with, right? So this is the one that we're looking for. So we don't know the v initial. Now what do we know? We know that the a is just negative 9.8 meters per second. What else do we know? We know that the VF is equals to 0. Now, why am I saying the VF is equals to 0 at this point? It's because, remember, the ball is going to reach a maximum point. If it reaches a maximum point, it's what? It's going to be 0, the VF, right? How do I know that? Because it's even shown in the diagram itself. And I'm even given the height at which it reached the maximum point, which is 8. So the change in Y, it's equals to what? It's equals to 8. Yeah. Now, what can I write meters here? Which equation am I going to use? I'm going to use this equation of V F squared is equals to V initial squared plus 2A change in Y. Now, from there on, my VF is 0, my V initial, and substitute, and 8 and 8. And from here on, my answer, or your answer, should be 12.52 meters per second. That is the speed at which this ball leaves the ground with. All right, now moving to the last one, which is 3.3. They want us to draw. Oh wow! Draw a velocity versus time graph for the complete motion of the ball from point A to B. Show the following on the graph: the magnitude of the velocity with which it hits the ground, the magnitude of the velocity with which it leaves the ground, the time taken to reach the ground, as well as the time it takes to leave the ground. Okay, seems fair enough. Huh? Good. Now let's begin and start to draw this. Now, since I said upwards is positive for mine, we're gonna do this. You're more than welcome to say downwards is positive. Everything that I've done right now, you do it in the opposite way around. I just feel like upwards, it's the direction in which the ball went, so it's more comfortable with that one for now. But if it was, let's say the ball was dropped downwards, I would use downwards positive. But then, yeah, you're more than welcome. Use the one that you feel comfortable with. You don't need to impress anyone in the exam room. Just impress yourself, right? Good. All right. Now, what do we know? We know that the upward is positive. We know that they wanted us to show the velocity. Right? Let me see. They wanted us to show the magnitude of the velocity at which it hits the ground. Of which, what was that velocity? Did we even calculate that velocity? Yes, it hit the ground with 12.52, right? And the VF, oh no, it hit the ground with 19.4, right? Okay, so the V initial basically for now, it was 10, then it hit the ground at negative 19.41, and then it went up again with the initial speed of 12.52. It lost some of its energy, that's why the velocity is 19.41. And the time, remember that in the beginning it was 3, and then after 3 it took 0.2 seconds, I assume. Yes, it took 0.2 seconds, so it's gonna be what? It's gonna be 0.2. 0.2. Then you're done. You just need to draw your line. So it began here and it went down. Right? Began at 10 with its V initial. That's right there, V meters per second, and the change in time. It went down and hit the ground. Let me try to make it much better because it has to align with the 19, right? Sorry, let me do this. Right. Good. I think this is much better than those lines I was drawing right now. So it has to align with the 19, right? So I have to make it more steeper and to be like this, and it hit here. Obviously, it need to indicate this. All right, since it bounced, it was in contact with the ground for how much? For 0.2, and of which this is the 0.2. Then we're gonna start here. We went upwards with what? With a certain speed, which was the v initial, which was 12.52, and we're done. They didn't want the velocity at which it hit the ground when it came back. So yeah, this is how your graph should look, and just like that, you are done. So you would get a mark for basically the lines, and for the lines of which that are parallel, right? Since as long they're parallel to each other, then yeah. So yeah, if you had said downwards it's positive, let me draw that one here. Your graph would look like this, with everything that I had drawn on top being opposite. I'm just gonna do a quick sketch of it. I'm not gonna draw it like to be perfect. So remember, you said downwards is positive. So as the ball went up with negative with 10 meters per second, this means it's gonna be negative. And then let me do this. And then here it's gonna be negative 12.52, and 19.41. So it went up with what? With 10. This is what? This is 3. This is 3. And then 3.2. Remember that it went up with the velocity of what? Let me try and make it the 9 instead of, yeah. It went up with this velocity. So yeah, this is how you would draw yours. Yours should be like this. If you set downwards is positive, it's just the opposite way around. Yeah. Upwards is positive. Right, good. So yeah, that's how you're supposed to draw it.